Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 59th Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 59 is XOR decryption. Each character on a computer is assigned a unique code, and the preferred standard is ASCII, American Standard Code for Information Exchange. Interchange. For example, uppercase A equals 65, asterisk equals 42, and lowercase k equals 107. A modern encryption method is to take a text file, convert the bytes to ASCII, then XOR each byte with a given value taken from a secret key. The advantage with the XOR function is that using the same encryption key on the ciphertext restores the plain text. For example, 65 XOR 42 is 107, then 107 XOR 42 equals 65. For unbreakable encryption, the key is the same length as the plain text message, and the key is made up of random bytes. The user would keep the encrypted message and the encrypted key in different locations, and without both halves, it is impossible to decrypt the message. Unfortunately, this method is impractical for most users, so the modified method is to use a password as a key. If the password is shorter than the message, which is likely, the key is repeated cyclically throughout the message. The balance for this method is using a sufficiently long password key for security, but short enough to be memorable. Okay. Your task has been made easy, as the encryption key consists of 3 lowercase characters, so A through Z. Using this file that I've already saved, a file containing the encrypted ASCII codes, and the knowledge that the plain text must contain common English words, decrypt the message and find the sum of the ASCII values in the original text. Okay, so several different things going on here. One is we have to find the encryption key. One way that we know we have found the encryption key is if the plain text contains common English words. In order to know that, we have to convert the text. We have to perform the XOR operation with the key, and we have to perform the operation with the key, and then convert from ASCII to characters. So I've done a couple of searches in preparation. One is converting. So Python gives us a method to find the ASCII code for a given character. And there's also a method in Python to get the character based on an ASCII code. So that's not a problem. Python also gives us an XOR function. Oh, goodness. Sorry about that. So let's go ahead and copy this problem statement. Go in and create our file for problem 59. because I did not commit problem 58 yet. I'll have to do that in a second. So, first we obviously have to read in the file, and actually let's go ahead and open this file, and it's just a very long string of comma-separated ASCII codes, which is great. Combinations of lowercase characters for each convert to ASCII codes and perform XOR function to decrypt file convert the decrypted message back to characters and the test that I am going to do is if decrypted message contains the or the print decrypted message and sum up all ASCII values for decrypted message. Obviously, there's an assumption I'm making here, which is that this contains the word the. It's not a totally unfair assumption. The word the is one of the most common in the English language, and we can't just look for letters. But let's see how well this works. So first, we're just gonna yoink from this previous problem. So f equals, we gotta open, and instead of that, it's 59 cipher, and we're going to call this cipher, and this should give us a string array of the ASCII characters here. Or the ASCII codes, I should say. They are going to be represented as strings, though. List of string. So we open the file, we read it, we close it. Then alphabet is equal to B, W, X, Y, Z. I think that's the whole alphabet in order. Okay. And in order to find these combinations, there actually is a tool for this in Python. Python Lex combinations. What's this something? itertools.combinations module. That's what I want. I didn't want that there. And at this point, let's go ahead and go back to grab these two lines that we always love to use. So first we have our alphabet. Possible keys equals list combinations. I'm actually going to do alphabet times 3 here to just give us a very quick and easy way of representing the fact that AAA is one of the possible combinations. So I'm actually at this point just going to go ahead and print possible keys. I obviously don't want to have it just do that for realsies. But that'll give us some indication that we are on the right track. Not sure it is getting... Okay, so there's TTZ. Okay, so we're good. We're good. Never print that again. So for a key in possible keys, we want to first convert to ASCII codes. So I'm going to call this key codes equals chord K for K and Q. Because that is what this said. Yes. And I'm actually going to change this to a C for character. And that should give us the correct thing. Okay, so we have our key codes, we have our cipher. And what we need to do is... So ord returns an int. So if we do this, cipher should now be a list of integers. Cool, cool, cool. I don't know about the letter C being correct here, but that doesn't really matter, honestly. Okay, so how would we go about converting our decrypted message back to actual characters? So we have our cipher, which is the list of events. We have our key codes, which is a list of events. So I'm going to make a variable called key index equals 0. And then for I in range length of cipher, decrypted cipher is just going to be that. So what we want to do here is say effectively key codes of key index XOR cipher I. And that's the XOR value, and then we want to put the decrypted cipher, we want to put the XOR value, I think. We'll just kind of go with it, see if it works. And then obviously the key index is, since the key is a lot shorter than the length of the cipher, we're going to have to deal with that. So the key index we're going to increment by 1, and then if the key index is ever greater than or equal to, it should never be greater than the length of key codes, then we just set key index to 0 again. Now, we're actually still in this first comment. So for decrypted message, how do we get that? We do another list comprehension, and we're going to say, what is it, CHR of C for code, for C in decrypted cipher. Join and then if the in decrypted message or the in decrypted message, print decrypted message, break at that point, and then we're just going to print the sum of the iterable, because guess what, we can do that. Python makes our lives easy once again. Okay, so run this, see what happens. Well, immediate issues. I know why. Okay, so I'm doing a lot in the same line a bunch of times here. Okay, so that's gibberish. But somehow contained the word the, I think. Let's double check this right here. Yeah, it's right there. Okay. So. Instead of the and the, let's look for and. The or the, and. Wow, okay. So, obviously a little bit harder. I wonder... what other common English words we should be guessing. So, kind of obviously... we're kind of stabbing in the dark. Let's see, so we're getting ADA here first. Let's Google common English words. Okay, so the B2 of... Let's see if that gets us anywhere. No. End by. Okay, so we're getting closer, I think. Let's add of. Oh, that's right there, so that won't get us anything different. Let's look for that. Okay, so now it's taken a little bit longer to think about this. Okay, that looks a lot more like English. Okay, an extract taken from the introduction of one of Euler's most celebrated papers. I'm not reading all of this. Let's see if this answer is the correct answer. The key that we found is EXP. And it is. Okay, so I'm not sure what strategy for picking these words other than going to Wikipedia and putting the first few. I skipped A and N because, come on. But so far as the actual algorithm goes, after picking these keywords, it's literally just going through the list of possible encrypted values or possible encryption keys. And you may already know, but this is how hacking is actually done. Just brute force trial and error a lot of times, which is why you should have long passwords. Because it makes it so they have to try more combinations. And let's see, so this solution ran in 534, 542, 7 seconds. Obviously well within our minute mark. We got the correct answer. I'd say the hardest part of this code to understand is going to end up being the fact that I did a lot of things in the same line. Like here, I could have broken this down into multiple lines because I'm doing a list comprehension inside of a join just to get this looking like English. So I can do this if statement. And then, yeah, relatively simple so far as what you actually have to do once you get past the fact that, like, there's all of this language about ASCII codes and encryption and decryption, and XOR, which this part I'm not sure how I would do without a built-in function. So, yeah, that's it for that one. Got the correct answer in time. We printed out the decrypted message just so we can verify we got the correct answer. And that's it for that one. I'll catch you in the next.